Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for running your awesome app. You'll want to make sure that your users don't have to put up with bugs, so you should use Rollbar for tracking and aggregating your application errors to find and fix the bugs in your application before your users notice they exist. Use the link rollbar.com/podcastinit to get 90 days and 300,000 errors tracked for free on their Bootstrap plan. And you can visit our site at pythonpodcast.com to subscribe to our show, sign up for our newsletter, read the show notes, and get in touch. To help other people find the show, you can leave a review on iTunes or Google Play Music and tell your friends and coworkers. You can also join our community at discourse.pythonpodcast.com to talk to previous guests and other listeners of the show. Your host as usual is Tobias Macy, and today I'm interviewing Steve Penrod about the company and project Mycroft, a voice-controlled, AI-powered personal assistant written in Python. So Steve, could you please introduce yourself?
Sure. Hi, I'm Steve Penrod, as you said, CTO of Mycroft. And so Mycroft, as you mentioned, is the open source world's answer to your Siri and Echo and any of the voice assistance platforms. That's what we're looking to build, is what we can use in the open source world.
How did you first get introduced to Python?
I think, back in college, I had a lot of interest in all sorts of programming languages in general. Everything from Lisp to Ruby and those sorts of things have caught my eye. I think the first time I was using Python actively was a couple of years ago when I started using it mainly as a scripting language for operating system, building on top of operating systems, sort of a shell extension approach.
So you mentioned briefly what Mycroft is. Can you describe a little bit more about, how it got started and how you got involved in it?
Sure. Mycroft was originally begun when the location where we're talking right now was starting up. It's a makerspace, and there was some interest in adding some sort of cool, geeky voice interaction. Everybody wants the Star Trek computer. And so they were looking around and they're trying to find something that they could use to do that. And there really just wasn't a great solution. This was a couple of years ago. So this predated really the release of even the Amazon Echo. So that voice interaction technology was cutting edge, is really just being thought of how we could do things. Especially, there were a few things like the Siri systems where you could activate them, but really something that was listening to you all the time and that you could activate with just your voice and nothing else and just talk to it. That was still the thing of science fiction. So when basically after looking around for this, nothing came up, it was decided, all right, well, we're going to try it. So this is where there's a little bit of strange history. I actually was doing the exact same thing in Kansas City, about 30 miles away, not knowing these guys were doing it. And so we didn't join together until earlier this year in our efforts. But we both recognized the need for this sort of technology and we started building it a couple of years ago to allow, like I said, the Star Trek computer.
So you mentioned that this actually started as two different projects that have been sort of merged together. So I'm wondering what that process looked like, because I know that quite often varying code bases quite frequently bear little resemblance to each other, and trying to figure out how to piece them together can be difficult unless they're designed in such a manner as to be very modular. So I'm curious what that looked like.
Yeah, and we're amazingly similar and completely different. The technologies that we used, a lot of what I was using was built on top of JavaScript and even using PHP and some mechanisms like that and Apache servers. And none of those literal pieces of code are going to exist in Mycroft, but conceptually, we were doing very, very similar things. And so it's been pretty easy for me to, adopt the things that I had built that were architecturally different and that I wanted to incorporate into the Mycroft project.
And how is it that you actually found out about the work that was happening in the makerspace, or that they found out about the work that you were doing so that you were able to sort of join forces?
Interestingly enough, we were both talking to the same guy at Google, looking at potential for collaboration. And this was before Google had made any announcements about their interest in stepping into the voice interaction with the Google Home project. And so I had some old friends and friends of old friends who were working there and introduced me to this guy. I'm talking with them and almost the same week, the Mycroft guys were speaking to him, and he asked them, he said, "Do you know this guy? Because you guys are like 30 miles apart and you're building the same thing." So it was pure serendipity, and since we've discovered, we were both at the Kansas City Maker Fair, a year and a half ago, a couple 100 feet apart. And, we've been crossing paths, just missing each other the whole time. So
that's pretty funny.
It's like somebody wanted us to get together, and finally we actually paid enough attention to do it.
And how is it that you decided to grow a business out of this project? Because I know that you said it started off as just sort of a hobby interest that you wanted to build up. What is it that made you realize that there was actually a business opportunity behind it?
Well, for me personally, when my interest in this goes back quite a ways, I'm going to date myself a little bit. So back in the 90s, I worked for Autodesk for about a decade. And while I was there, one of the pieces that I helped develop when they were coming out with the original tablet PC from Microsoft, that was, for the younger listeners, they didn't have touchscreens on laptops back in the day. And they didn't do things like voice interaction and being able to draw on your screen with a pen. That was all kind of new concepts at that point. And so I was building some demonstration software on top of Autodesk products that when they were introducing the tablet PC, they could show off on stage what the capabilities of this was. And one of those pieces at that time, Microsoft had the speech API available. I think it was like version 4, maybe 5 at that stage. And so from a personal interest, I just started what really boiled down to is I wanted to be able to play my music through that and be able to voice control my music collection because it was kind of big and it was cumbersome to interact with it in any way. And so I was looking to see if I could build a voice interface to allow me to say, play, Heart Attack and Vine by Tom Waits. And the short answer is I couldn't back in the time frame. The pieces just weren't ready for it. Technology-wise, speech API was okay. You had to do sort of command and control where you preloaded it with a fixed vocabulary, which maybe was doable. What I was looking at loading, thousands of words or tens of thousands of words, it wasn't really well suited for. And then on top of that, the hardware at the time, microphones were hundreds of dollars. And this predated, the pervasive Wi-Fi. And so you really were talking about running cables all over your house if you wanted to be able to do this. And it just boiled down to you couldn't do it. So, I abandoned that idea in the late 90s. But then when I finished the last company I was involved with, finished at that startup and was trying to decide what I was going to tackle next, I started looking around at the world that had developed, and things that had changed. And it struck me that today's technologies with the single board computers and the power that was possible there, that now was easily as powerful as the desktops back in the 90s. And the speech to text technology on the desktop machines was better, but also the cloud, especially a couple of years ago, was just ramping up. And so these cloud approaches where you were able to throw even heavier duty processing at it and where they were able to collect massive amounts of voice data to train their systems, those were making leaps and bounds forward. And then finally, microphone technology. The joys of cell phones is they've made microphones in huge demand. And so the mics of today are easily as good as the mics that cost hundreds of dollars. Honestly, it's probably $500 for the quality of mic that we're talking about in our cell phone today that costs, $2. So all of those pieces came together to where it struck me after I did a little prototyping that what I had thought about building back then was suddenly in reach. It was capable to build this. And similarly, not to the exact same story, but within the Mycroft makerspace, everyone was going through kind of the same kind of process, thinking through the technologies that are available today and realizing that they could build something like that. And so I think this happens with a lot of technologies. There's a time where it is ready to emerge. And, you see that if you even going back to, the light bulbs or, the automobile or planes, people around the world that had no knowledge of each other are simultaneously developing these some sort of technology that's just the world has come to a place where it's now ready to support that technology. And I think voice interaction like this, it's just time for it.
So can you dig a bit into how Mycroft is architected internally and some of the biggest challenges that you've encountered while working on building out this product?
Sure. There's a little piece of the story that I think I left out that's of interest when it comes to the architecture. Originally, when they started building this for the makerspace, they realized, if we want this, probably other people are going to want it too. So that's when they looked at the idea of doing, Indiegogo Kickstarter projects with it. And so that's really what funded it and got it going from just a couple of guys kicking around an idea to a business. And so, had a strong demand emerged out of that. And that started the Mycroft device, this project that they were building. And so originally that was going to be, if you go look at mycroft.ai, you can see this cute little enclosure that you look at it and it's got big round eyes and a matrix display in between that you can see its mouth moving and smiles and things like that. So it is a very interactive piece of hardware, very engaging piece of hardware. But as this was being developed, we recognized that there were a lot of things we were building that could be used outside of this specific piece of hardware. And so a little bit, I won't say it hadn't been thought from the beginning, but somewhat midstream, there was a little bit of a shift to make sure that it would be possible for this core that we were building. And so we ended up calling it Mycroft Core to exist independently of the hardware that's enclosing or that's wrapping this piece of software. And then you could wrap that software core with your enclosure, which might be a simple smiley little robot box, or it might be a refrigerator, or it might be a desktop, running a Linux distro. But as far as we were concerned, it doesn't really matter. It's just piping in the audio data that we process and we do some stuff with, and we return to it audio data that the enclosure, whatever it may be, can play out its speaker, presumably. So then the other piece to what we were building, the other architectural piece that is critical for this to be a successful and really useful technology and not just a toy, is we don't want it to only be able to do a handful of things that we make it do. We really know that in order for this to be what everyone imagines it to be, it needs to be extendable. And so the other side, you've got people making different enclosures, but then the other side of that is we need different kinds of skills. And I think that terms become associated with voice systems a little bit here. And so you can create a skill that can, for example, control your Philips Hue lights, or a skill that can reach out to your favorite website and scrape some data from that, or access a web API and bring back a result and then speak the result to you. And so the intention is that we would build a handful of these skills, but honestly, those are just examples for the rest of the world to reference and build the things that they imagine and to support the services that they have, already built. And they just want to allow somebody to be able to interact with those services using their voice, or to control the Internet of Things devices that they've built. And, I don't know if you've played with any of the IoT lighting systems, but the reality of having to pull out your cell phone and pull up an app and flip to the right screen and tap a button to turn a light on and off, it's just not that great. You want it to just happen. You want to say, turn on the lights or dim the lights or turn off the lights. That's good. Or, some of the things that we're going to be coming out with is you just walk into the room and it knows you're there and the lights come on. That's what you're really imagining the Internet of Things to be, where the environment is immediately available and controllable by you without any effort.
And I know that when you go to the projects page on Mycroft.ai, there are a few different libraries there. So there's Mycroft Core, which ties it all together, but there's also a couple of ones for the speech-to-text and the text-to-speech, as well as the AI routines. So I'm wondering if you can speak a bit to those different projects and what the current state of them are, respectively.
So there are a couple of different pieces that are necessary to create a voice interaction system. And one of them that you would start with is the conversion of your voice, the speech to text. So speech to text is an encapsulated technology that we're very dependent on and interested in. And at the moment, we've got a tool that we've started to build called Open Speech to Text. We're not completely sure we're going down this path. There are a couple other options, but we've been looking at Caldi, which is another open source project that's been out there. We're looking at building on top of that. A lot of what we've done is really standing on the shoulders of giants. Other people have built things and we're continuing that work. Then another critical piece, once you've done that, speech to text, is figuring out what that text means. And so there's a phrase that we use called intent parsing or intent processing, where you're trying to figure out what's the intention of those words that the person just spoke. And for that, another piece that was built, and this one was largely built for the Mycroft project. Sean Fitzgerald was one of the early guys involved in Mycroft. It allows you to define keywords to identify within those phrases skills that the phrase is intended for. And so we use that to say, when I say turn on the lights, to recognize, the intent is to deal with the light system, and on is the action that we're wanting to take. And so then we can pass that off to the skill to handle it. Then once you get a response from that, you need to take that response that's coming back in some form and speak it to the user. So that's the next piece of technology, is text to speech. And we're using a system that we built on top of an open source project called Flight, which, the whole text to speech world. Flight was actually built on top of Festival. So there are generations of text-to-speech technologies built on top of each other. Mimic is the name of the package that we've done. Then the final piece, which is Mycroft Core, is what pulls all of those bits together: the speech-to-text, the intent processing, the intent parsing, and the text-to-speech, and pulls those together into the complete process that is Mycroft, the complete system that does that. But each of those technologies is actually self-contained and is usable in and of itself.
And when I was looking at the list of projects there, I noticed one of the things about the Mimic project is the intent for it to be able to have a higher quality voice than the sort of traditional robotic voices that we've dealt with when dealing with typical text-to-speech programs going back to our, original cell phones before they gained any sort of intelligence. So I'm just wondering, I guess, what are some of the approaches that you've taken there and some of the problems that you're needing to overcome?
Yeah, this is one of the things that as an aside, one of the things I really like about this problem that we're dealing with is the ability for us to take all these technology pieces that we're building and apply them in lots of different ways to help people in ways that, a decade ago just wasn't possible. One of our tagline is AI for everyone. And what I like about that is the overloaded way we can use that. When we say everyone, partially it's, making things available to the elderly and to, people who previously, because of maybe physical reasons, they can't use a keyboard, so they weren't able to use a computer. So now we're able to enable that. Other ways where it's useful are where we can take pieces of our technology and make them available to other groups to build as building blocks that they can do interesting things with. The text-to-speech in particular is an area where there's a company called Vocalid out of Boston, and their business is built around the idea of, or their effort, I should say, is built around the idea that all of the text-to-speech voices that exist, there's a limited number of voices. It's getting better recently, but there were, especially when they started up, really, there were only a handful of voices that someone who had to use an assistive technology had available to them to use as their robot voice or their surrogate voice. So if you're a 11-year-old girl who can't speak and has to use some sort of an assistance to speak, you really don't want to sound like Stephen Hawking's voice as an 11-year-old girl. You want to sound like an 11-year-old girl. And so that was their charge, was to build this bank of voices to enable them to enable people to build lots of different voices and personalize that. Their goal was to do it to assist handicapped people or people who had some sort of reason that they weren't able to use their own voice. We've been able to work with them in partnership with the Mycroft project. So they have built the default voice that we're using right now, which came from Alan Pope, who's a community manager in the Ubuntu world. And we're going to be helping them in acquiring some of the recording data to be able to build more voices. So it's a virtuous interaction we have going there, where we can help each other to help make the world better, honestly.
Yeah, that's very cool. I'm actually aware of the work that they've been doing because one of the founders of that project actually did a very interesting TED Talk about the work that she was doing and the business that they started up with that. So I'll add a link to that in the show notes. And as an aside, for anybody who has a few moments to spare, they actually have a space where you can go and donate your voice to contribute for them to be able to build new voices for people who do require assistive technology for being able to speak, so that they can have more of an individualized voice than what is generally available to them.
Sort of thing that just makes you feel good about yourself.
And I know that the speech-to-text aspect of it is actually one of the more difficult problems in the overall voice interactive space. So I'm curious, I guess, what sorts of progress you've been able to make there. And also, one of the things that has made that a more surmountable effort lately is, as you mentioned, having access to cloud computing resources and being able to train those models on multiple different inputs, but an associated concern that comes out of that is privacy, because of the fact that your voice does get shipped up to a remote server that isn't under your specific control. So I'm wondering what you're doing to address any sort of privacy concerns around that, or if there's the possibility for doing offline training.
So the shortest answer is the offline bit is really not practical today. There's just too much for the small devices that we're talking about. You're never going to be able to do that sort of processing on a Raspberry Pi class of device. There are a few technologies that are being used in situations where, there's no internet connectivity or for other security reasons. I know a few military type applications where they didn't want to have that going on. But those are more limited vocabularies that they're able to handle. So if you're really talking about being able to take conversational speech like what you and I have going on right now and converting that into text as a free-flowing thing, in the near term, that's going to have to involve some form of cloud interaction. As of today, that means we've got to do some form of cloud interaction. And the choices that we've made while we're building the open speech to text technology is that for a voice interaction system to be valuable, you have to have really high quality speech to text. If it has a 20% error rate, 80% sounds okay maybe if you're taking an exam. it's an okay score. But if you're trying to use that to control things around your house and, one time out of 5 it gets it wrong, that's just irritating and you're going to stop using the technology, whatever it is. So for today, we've chosen to go with by default, the strongest speech to text engine that's available to us, and that's been the Google speech to text engine. But privacy, as you mentioned, is one of the things that really jumps out when you're talking about voice interaction technologies, because by their nature, they're listening to every word you're saying, right? So the first stage of privacy is that the actual every word you're saying listening that goes on, that does occur locally on the device that is running the system. So on the Raspberry Pi, we've got a piece running that's built on top of Pocket Sphinx that is doing what we call wake-up word processing. So what that basically means is your microphone is constantly listening to every sound coming out or coming at it, and it's trying to do some analysis to see, did you activate the system? In our system, it's Mycroft or Hey Mycroft. That's what brings its attention. You see wake-up word technologies used in the other systems. If you call up Alexa, that's the wake-up word for that, or the OK Google phrase on the Google products. And so that wake-up word technology is the first protection of personal privacy. Now, that leads to some of the value of open source technologies versus closed source technologies. If you want to know on a Mycroft device, or Mycroft system, is it listening to me all the time? You can pull up the code and you can look and see what the code does with that audio stream coming through, and you can see, okay, yeah, they're looking through this, they're looking for the wake-up word, and then that's when they trigger the connection to the cloud to perform the speech to text. If you're looking at an Amazon system or a Google system, it's more opaque what's going on. You're asked to trust that someone is doing the thing that I just described. And, I completely believe they are doing that, but there's no way to verify that that's the case. So that's one of the first levels of privacy protection that an open source system gives you. So the next level of privacy protection that we're implementing is when you are talking to one of these systems from a traditional company, they have commercial interests, and they have lots of other things going on that they're wanting to tie you into their systems and support their systems. And so, for example, every time you're doing a voice interaction with a Google device, it knows that it's you, Tobias, that's talking to it, or it knows that it's me, Steve, that's talking to it, but based on my either the login session that I have going on my browser, or my cell phone association, or whatever. And so they are able. Again, I'm not saying they're doing it, but they do have a very tight coupling between the information that they gather and the voice that is transmitted to them. So they know the identity of the individual speaking to them. And so that's one of the areas where we're, again, able to do some even using some of these proprietary systems, we're able to put in an isolation layer. So we break apart. They know that a Mycroft device is speaking to them. This voice data is coming from a Mycroft device, but they don't know for sure who it is that created that voice data. There's no connection between the user identity and that voice data that's going out. So today, that's the level of protection that we're able to offer, is that anonymity to the voice that we've created.
So as far as the artificial intelligence aspect of it and the sort of adaptive intent parser, I'm wondering what kinds of machine learning approaches are being used and whether they also require a remote system for being able to execute, or if those run locally on the device.
This is going to be a little bit of a long answer. The way that we're approaching it right now, today in 2016, is the adapt system that powers Mycroft is much more procedural, I'll put it that way, and the way it does the intent parsing. But what this does is it's laying a framework for us to be able to start gathering the information that we can use to do some classification and have a more free-form, flexible intent parsing. And so part of that requires we've got to have a lot of users and a lot of interactions for us to start building the data to allow a learning system to really learn well. And so, but we have done some prototyping. One of the Jonathan d'Orleans, one of the developers on the Mycroft project, he's got a educational background and a lot of personal interest in artificial intelligence techniques, and he has built a thing called neoevolution. And so that's a framework that he's created for a evolutionary artificial neural network. So this pulls together a couple of different concepts out of the AI community. So neural networks, everyone's heard of these things, and deep learning and genetic algorithms. He's pulling all of these things together. And what it allows is the neural networks, it allows them to evolve better than the way they traditionally have been implemented in the past. And so we're then able to use it. That framework is capable of doing a lot of different things, prediction problems and classification problems and, even playing games. It's capable of learning lots of different things. So he's built this framework, and we're prototyping using that framework to take some of those control phrases and just be able to toss them out at it and let it learn. So for example, today, going back to the lighting control example, a programmer would have to say, these are the words that I'm interested in, lights and on and off. We'll just stick with those simple ones. And so if the adapt system is able to identify that you're interested in lighting and the action is on or the action is off. And we've got some flexibility in the way you can throw those words together, but it has to be those things that the programmer has thought about. They have to do some pretty explicit thoughts of what the activation phrases are that a user is going to have. What the neoevolution will allow us to do is take a whole bunch of different phrases that either we've come up with or that the skill developer comes up with when they're developing their new skill, or we can do opt-in mechanisms where the unrecognized phrases that someone tries to speak to a device get reported back to us, and we can start throwing those into this system. And so instead of saying, turn on the lights, you could say something like, it's too dark in here. Hey, Mycroft, it's too dark in here. And it can figure out from that the intention is to turn on the lights, even though you didn't use the word light or on. Those would get lumped into that intention. The approach that we're going to be doing with that is a thing called, there are a couple of different ways of doing that. So there's supervised learning and unsupervised learning. We're going to be doing more of the supervised learning, where we're throwing it into, this is the batch of stuff that your phrase corresponds to. We're looking at a few other approaches to how other ways we can enhance the experience down the road, but that's our first approach.
You referred a number of times to running this on a Raspberry Pi, but you also mentioned the ability to run it on essentially anything with a microphone and speakers. So I'm wondering, I guess, what's the minimal amount of resources necessary for being able to get this up and running, and what does that install process look like for somebody who wants to start tinkering with it for themselves?
Part of the architecture is we wanted to have a lot of flexibility in all sorts of different ways. That's been one of the challenges of it. And so one of the ways that we want to make it flexible was the computational resources, the demands you have on there. So the sort of the default implementation of Mycroft right now, so if you pull it off of our GitHub, make use of it the way it's configured by default, the system that gathers the audio data, that's, of course, running locally. Doesn't take up much computational resource to do that. Then it reaches out to the cloud to perform some speech to text. And so the computational resource there is away from the device. Then the speech to text result comes back down to the device. And that's where we're doing the intent processing. So that's occurring under the adapt system locally. Then depending on the particular skill you trigger, that may or may not occur on the device that you're running If you're saying, what's the weather like, that's obviously going to reach out to a database somewhere in the world, or not a database, but an API somewhere in the world to pull that data down. If you say, something along the lines of set a timer, that might all be running on the Raspberry Pi itself or whatever your device is. So there's a little bit of variability on the computational requirements for that. Then the last piece by default that we do is the text-to-speech through Mimic is run on the Raspberry Pi. So that probably the single highest computational consumer on the Raspberry Pi is that process of going through the text and generating the wave representation of that and speaking it. Part of our architecture, though, is allowing us to switch things. So the speech-to-text engine, as I said, the default is that we're using the Google speech-to-text right now, but we also can switch between different providers. We have worked with the IBM Watson technologies coming out of there. We've worked with our own open speech-to-text. And so any speech-to-text mechanism you can connect up with. Could even involve a local one if you wanted to have a complete offline system. We haven't attempted it, but it would certainly be possible to hook into, Dragon systems and some of those that have pretty decent local speech to text could be connected into our system, and that could be a cloudless implementation. On the other side, the text to speech that we do by default, like I said, is Mimic, but we also have hooked up to other systems. So we could connect up to the Google text to speech engine, or iSpeech's text-to-speech engine, or one of a dozen different services that allow you to send off to the cloud, and it pulls down a wave representation. And in that case, there's very little processing used to perform the text-to-speech on the local device. So that's part of our intention, is that the Raspberry Pi implementation, we're getting pretty much the most out of it right now, and using Mimic would be a challenge on anything with much lower processing power and memory than a Raspberry Pi does have. But if you started using a cloud text-to-speech, I think there's a good chance we could get it down to the level where you're able to run on, probably not a microcontroller, but, some of the very, very simple system on a chips, things running on your watch and those sorts of things.
And for the actual install process, is there any sort of easy to follow installation guide, or is it still sort of a work in progress?
So currently the easiest way to get started if you're running on Linux is you can pull down our system from GitHub under github.com/mycroftai. All of our code sitting out there are available for you. And if you follow the Getting Started guide that we've created at docs.mycroft.ai/development/getting started, that will walk you through the process of pulling it down. There is a stage. The vast majority of what we do is in Python, but Mimic is C++ code, so you do have to go through a compilation stage on that one. And I will warn you about that one. On a Raspberry Pi, it takes a while. You can start it and then go have dinner, but you only have to do that once. Beyond that, it's all Python based, so it's pretty straightforward to get going with it if you're familiar at all with Python.
And are there any distributions of Linux that are more well supported than others?
We're working with Ubuntu for a while, and I can't. A few things I don't think I can really drop names yet, but we're talking to some other people about things, and I think there's going to be a lot of tight collaboration there. The open source world, the Linux world, is recognizing that they need their version of Cortana and Siri, and I'm happy to say that they seem to be recognizing us as the technology that is likely to fill that gap for them, and they want to work with us in integrating this into lots of different systems.
So essentially, going back to the Raspberry Pi example, if somebody just installs the Raspbian distro, then they shouldn't have any issue with getting this set up.
Yeah, it should be pretty straightforward, and we're getting where they can pull it down off of, using the standard distribution methods. We've got a few packages being built, and so those are going to get easier in the very near future for people too. They just pull down as a package and be up and running.
So there are a number of success stories, but also a number of failures in terms of trying to run a business based on an open source project. So I'm wondering, what are some of the benefits and challenges that are introduced by the fact of making the software that powers Mycroft so freely available?
It is, our greatest strength and our Achilles heel, I guess. I think what really makes this into a compelling story is people recognize it's kind of creepy to be listened to all the time by your computer. And what is it doing? That is something that is a huge privacy concern. At least I can turn off my laptop, or I can, leave my cell phone in the other room and walk away from it. But the world we're looking at moving into, and in the very near future, is that there's going to be a device in every part of your life that's listening to your words and listening ambient voices floating around and wondering, as an individual, I've got to wonder what is happening to that. And I think that the open source approach is really the only way to satisfy people that their voices and their privacy are being respected. And so that's the biggest strength of Mycroft, and that's what distinguishes, I think, from everything else, is the fact that we are making all of this available to the world to look at what we're doing, and we have no secrets about it, and we're not hiding anything, and we're inviting people to come and look at what it is that we're doing with the sensitive data that we've got. So that's the advantage of it, and the other advantage also beyond just the privacy is the fact that there are so many things you want to do with your voice. If you just stop and think about, if I could talk to my environment, and this is actually how I got started on the project years ago before I even built a single thing. I was just walking around my house, and people probably thought I was insane, saying out loud commands, the things that I would want to do, and walking through that process in my head. And there are lots of things, and I can't build all those things. And any team of a dozen people or even 100 people can't build all of those things that the world wants to do and control. And so one of the cool things about the fact that this is open source is we can put it out there and enlist the help or make it available for others to join in on the effort. And people can reference other people's designs and other people's clever ideas. As we're doing voice interaction, this is a brand new thing. I liken it to back in the 90s or the late 80s even, when we were first creating GUIs. And if the idea of a checkbox and a radio button and push buttons, those are so simple to us now, and they seem so obvious, but they weren't actually back then. I can point to some really early, Windows implementations where they hadn't really figured out the difference between a radio button and a checkbox. People mixed and matched the way those things interacted because the patterns of usage hadn't been established yet. That's where we are today when it comes to voice. How do you use your voice? How do you categorize? How do you direct when there is no, it's really boundless. The context of what you're trying to do inside of your head, the computer doesn't have many indicators of what that is. You don't have an active app that's on screen. It could be anything that you come up with in your head. So how do you figure out and categorize contexts and interactions and phrases? Some of the things that I've come up with, there's phrases like show me to indicate I want something to appear on a screen and to be shown to me. I think those kinds of interactions are going to be developed, and those techniques to respond to it are going to be developed. And as an open source mechanism, people get to build on top of each other's efforts. And I think it's going to accelerate the rate that we're able to make all of these different things that we want to interact in the world, to make them available to us. And so that's one of the great powers of the open source efforts is coming together to do this. Now, you ask, of course, what's the flip side of it? What's the cost of it? And for us as a fledgling business, when you're talking to an investor in any business, one of the first questions they ask is, how do you make money? That's what drives the business world, and that's what drives investment, is return on the dollar. And so the idea of handing off your intellectual property, that's for years, there were the patent wars going on, and everyone was protecting stuff. And so to these investors, it makes no sense what you're doing at first blush. It scares them away. And so for us as a business, it has definitely been a challenge finding investors and investment that is willing to jump into something where it really is a big long-term project, and the payoffs come as we build this for the world and as we make this thing available. That's how it becomes a viable thing. In the short term, we're not going to generate millions of dollars on your return. So for some investors, the fact that they have to wait to get a result from this challenging technology, they'd rather go invest in somebody who's making fancy shoelaces that they can sell in 2 months and see a return on that, a profitable return on that. It's a tricky sell. Fortunately, we do have a few examples that we can point to, projects that have succeeded in handing off their source code. The Linux, obviously, in and of itself is a huge success, and its humble beginnings as this little project that grew and grew, and now it's suddenly underlying technology for so many devices that people don't even recognize. The Wi-Fi routers that they depend on, they don't know what's running it under the hood, or the gaming systems that they're using, or the phones that they're doing, the underpinnings of Android. It all comes back to this little open source project that this guy started years ago. And so we have at least a few of those success stories to point to. Android itself is another open source approach. Some people might debate some bits about that, but it was an open project that was made available to all these phone manufacturers to pull it in to their equipment. So that makes sense to some investors now that they can look at those examples, but it is still a limited, very small subset of the traditional investment community that understands the value of this and why it is important to make this technology open and available for everyone.
Yeah, and going back to your point about the fact that you wouldn't have the time to be able to build all the different possible applications for this kind of technology if you just had a single team, not only does it increase the amount of actual work that can be done, but also it increases the diversity of the applications, because if you do just have a single team focusing on the project and the only input into what should be built are the people on the team or the people that those individuals are directly interacting with, then there's huge swaths of the global community who would be left out because of their particular cultures or their particular environments or varying levels of capability in various aspects. So that's another aspect of the open source movement that adds a lot of power and weight to making something like this open source. And then on the potential downsides, there's also at least perceived conflict of interest when you do have a business entity running an open source project, because you have to worry about what does the community engagement and community management look like, because, well, on the one hand, the community has their sets of wishes and wants that they would like to see present in the open source project. The business may have a completely conflicting set of ideals, and so you need to try and figure out early on what those governance models look like so that you don't end up with a situation similar to, for instance, what's going on with Docker, where there's the potential of a fork because people aren't quite happy with the direction that they're taking the project.
Right. No, I completely agree with you on both points, and that is something I left out. One of the big pieces of our technology that I'm hoping we can take advantage of is the international aspect of it. We've got people who are working with us in our Slack channel from literally around the world, and if you look at the current voice assistants that exist, it is very focused on English and the English language. The Echo device was only for sale in the United States, and they finally made it international by allowing you to sell it in England. So it's still a very small portion of the world that has access to these technologies. And even if you look at portions of the world where people are able to speak English, in speech-to-text technologies, accents actually make it difficult for speech-to-text to operate. So if you're, say, someone in India who speaks English very well, but you do have a definite accent, there's a good chance that the current generation of technologies don't work. And so I'm really hoping that we're able to work together with a lot of different entities as an open source project, university efforts that have been underway in doing speech to text in lots of different languages. I'm hoping that we can establish and solidify some of these partnerships with them to bring, Chinese and Japanese and even the smaller, more obscure languages that have been traditionally been ignored by technology because there just wasn't a large enough population to justify a commercial entity from investing a lot of effort in supporting them. So like you said, I really am hopeful that we're able to make the most of that as an open technology. But, as you said, the other flip side of it is a community. And we, Mycroft Incorporated, the hunk that I'm involved with as part of the community is just a part of the community. I don't get to dictate things. It is open to everyone. And so, we do recognize and we don't begrudge that. That's actually one of the great things about it is it helps keep you honest and it helps you make decisions based on larger point of view than just the side of the problem that you're looking at from where you're sitting today. And, it does have the dangers, like you said, of a forked project, terrifies so many people. But I'm willing to live with that risk. I think what we're building, the technology we're building is too important for the world to not be available for everyone to make use of and to be able to pull into things in whatever ways they see fit.
Bringing it back a little towards the beginning, how did the decision to write this project in Python get made, and what was some of the reasoning behind it?
So that was an early strategic decision, actually. Python, when there are some advantages to the form of what we're doing to a scripting style language rather than a compiled language. Being able to plug in and make it easy for people to develop things and be able to bring pieces in. It works well with a scripting language. And Python in particular stood out in both its capabilities as a scripting language, the object-oriented pieces we take a lot of advantage of that, but also the wealth of libraries that are available for people to be able to pull in and to be able to take advantage of those. As I said, we expect lots of different things to be built. And so access to all of these libraries just makes it easier for people to build things. So it felt like it was the right tool for those reasons. And then the fact that we want to be able to run this technology on lots of different platforms and capability platforms, high-end and low-end computational devices, we needed something that had broad-based support. And Python is one of those scripting languages. That's probably overclassification, but Python's one of those languages that exists very early on lots of platforms. So we liked that from a strategic standpoint. To any technology that we built, we wanted to be able to take advantage of that widespread distribution possibility.
And what do the mechanisms for extending Mycroft look like? Is it just a matter of dropping a set of scripts in a particular directory structure and having it pick it up automatically, or is there any sort of particular interface that's exposed from the Mycroft core for people to be able to hook into?
So there is an interface. We have the skill API. So it's a combination of what you just said there. If you're doing development today, the approach is there's a folder on your device that has your custom skills. And so you drop into that folder, you create your own folder for your skill, and you can have multiple skills, each in their own folders. And that, your init that goes in there, you derive from the skill API that we've exposed. And so there's a handful of methods that you would then extend and derive from, and the capabilities that it then provides you to write back to say, I want to speak these words, or I want these things to show up on a display. The skill API that you've derived from allow you to send those things out to Mycroft system. Beyond that, though, you can do pretty much anything your imagination comes up with. We provide starting point, so we come at you and we say somebody wanted you to do something. Here's the intent that we got from them of what they wanted to do, and then it's up to you to do it, react in any way you want, and then we also provide the mechanism for them to feed back to the user, say something or show me something on the display.
And what are some of the most interesting or surprising applications of Mycroft that you've seen people put it to?
So there are a couple of applications that have been developed for Mycroft itself that have been, fun applications using it. One guy had built a robot using OpenCV to do some image processing, and he combined that with Mycroft voice control. So the robot would be able to look at someone, track them, and you could say things to say, take a picture now, those sorts of things to be able to control this robot using its voice. We've done, obviously lots of things with controlling houses and lights and things like that. We've already had community members working on using it in different environments, running it on your Android system, running it on your Android Wear devices, controlling desktops. Those are kind of obvious, but it's also good to see that the ideas that we had when we were building this, we were able to run it in different locations are possible, are feasible, and are happening now. And one of the things that I got to participate in that was a completely unexpected style or usage of this. We went a few weeks back to a facility that GE runs called First Build in Louisville, Kentucky. And GE had invited us to go there. We'd been speaking with them about some potential things, possibly working together or showing them the sorts of things that we could do. And they invited us down to this facility, it's kind of a factory and a makerspace that GE makes available to the community. And they hold periodically different events there. And once a year, they have this weekend-long event where they pick a theme and people break up into teams and they build some sort of some sort of device around that. And the theme this year was the future of cooking. Well, I had Joshua Montgomery and I went down there. Josh is the CEO, and we were just going to go down. We didn't honestly know what we were going to do. We were just going to watch probably. But when they got there, they encouraged us to participate, and so we ended up joining a team with some college students from Art and Design College, and we chose cooking for the visually impaired and the blind. And so what we ended up building was an inductive surface stove that had Mycroft incorporated into it, so along with some sensor systems. So as you walked up to the stove, a proximity sensor from TI would trigger, and the Mycroft unit would recognize it, and it would warn you if it was active. If it would speak up and say, "Be careful, there are hot pans on the stove," and you could inquire of it which burners are occupied. You could set things like set the temperature. Those touch surfaces are great if you can see the lights indicating what's going on, but if you're blind, that doesn't really do you that much good. And so being able to interact with that using your voice was pretty cool. And then we also prototyped some concepts of, imagine trying to pour milk into a measuring cup for a recipe if you're blind and get that right is really difficult. So what we were looking at is while it's on the stove, you would say to the device, Mycroft, I need to add a half cup of milk to this recipe, and it would look up the density of milk, and it would zero out a scale built into the burner, measure the weight of the pot and the contents at that moment. Then you start pouring milk in, and it would say stop when it reached the weight that meant you'd put in a half cup of milk. And some of those things, to be honest, I would love to have in my own stove, not just for the blind. I think it'd be pretty cool to be able to just pour things in until I'm got the right amount. So that was a unique case. I talked about enclosures. That was an unusual enclosure. It's not a watch or anything like that. It's built into appliances and really seeing how far we could take the ideas of smart appliances. And I think the last one that really has surprised me in a good way, there were a few, this was built on one of those pieces of technology that we developed. So the Mimic text-to-speech, as I said, it is fully encapsulated text-to-speech engine that anyone can make use of, and received an email from a gentleman, Kendall Clark, who runs a distro of Linux called Sonar GNU Linux, and it's specifically designed for the visually impaired and enhancing the Linux desktop experience for people who are are, either blind or who have other issues with vision, color blindness and things like that. So he had taken Mimic and was incorporating it into the tools that they were using there. It was, he wrote us so excited that it was such a much more friendly voice than anything that he was able to find, and just thrilled to know that he could use it and incorporate it into his project. Those are the things that really get me going about what we're building here, is seeing where other people are bringing it in and honestly extending technology to people who have been left out of technology up until this point.
And what are some of the long-term goals, both for the Mycroft open source project and the business that you're using as a vehicle to power it?
Well, as a business, this is really our only interest is, natural language voice processing. That's what we're here for. This, I don't expect that we're going to diverge into self-driving cars or anything like that. So long term, what we're really focused on is how we can expand this technology from where we stand today to where it is available throughout your life. And if you think about the way you interact with any voice technologies today, it's a very fragmented system. Today you can say things to your Android phone, and you can make things happen with your Android phone. Then you walk over to your desktop machine at work, and it has Cortana, and you can say things to that too. But they're different things. And maybe they do the same things, but there's different syntax or different speech, or you have to set them up independently, configure them both. So that's kind of a pain. But then you go to your car, and maybe your car has Ford Sync on it. Well, it has another subset of things you can do, which is probably not all the things you can do on all these other devices. And you probably, the results are a little bit different there too. And same with your Apple devices. Again, there's this fragmentation that's occurred in the voice industry. And I think it's counter to the entire goal of voice interaction, is that it's supposed to be natural and easy and follow around doing what you want it to do. So when I say what's on my calendar, I want to know what's on my calendar. I don't want to have to explain, what's on my Google calendar at steve.penrod or anything like that. That's no longer a useful voice interaction. I want to be able to talk to it like I talk to a person, quick and easy, and it gets the context that's associated with me and with the location where I am. And so that's where we're looking to carry this technology, where the system is able to assist you throughout your life, throughout all the environments that you're interacting with. And when I say it that way at first, it starts, that's where the creep factor comes in. And again, that's the value of doing it through an open source system. We can build this in such a way that people have confidence in what we're doing is not being used in a way that they don't intend us to use it. And so that is our goal, is to carry this technology to its, the nth degree, make it available to people and do it in such a way that we retain trust throughout that process.
So are there any other topics that you think we should cover before we close out?
No, I think that was pretty good.
So for anybody who wants to keep in touch with you or follow what you're up to and what's going on with Mycroft, what's the best way for them to do that?
The best way to track what's going on is that you go to the website, mycroft.ai, and that has links to blogs and connections. We have a Slack channel that's mainly developers that are sitting in there, but anyone is invited to join in. If you don't have developer credibility, you can assist in other ways, concepts, translations. There's just lots of things that people can do to kick in. But you can get to all of those things via our website, mycroft.ai.
So with that, I'll move us into the picks. My picks today are, first off, the Yip project, which is a front end to pip, which adds some of the sort of aesthetic of the Yower project from Arch, which is one of the front ends to the Arch user repository. So it just makes it a little easier for searching for Python libraries and getting some information about them before you actually install it. And my next pick is the Myths and Legends podcast, which is a podcast of a gentleman who explores some of the various myths and legends from folklore around the world and tries to expose either versions that you may not be as familiar with or stories that you haven't heard before. And he does a good job of presenting them in an entertaining and sometimes amusing manner. So I definitely recommend people check that out if they're at all interested in some of those aspects of mythology and the different cultures that gave rise to them. And with that, I'll pass it to you, Steve. Do you have any picks today?
Sure. So my life at the moment is boiled down to sort of code and food. So I'm going to focus on the food side of things. There are a couple of picks would be, first one is just Ethiopian. If you haven't had Ethiopian food, you got to give it a shot. Try it. It's getting bigger. You can find an Ethiopian restaurant in most cities. Blue Nile in Kansas City is pretty darn good. And then the other one, as a Kansas City boy, as I've been traveling around the country, I appreciate the barbecue that we have in Kansas City. I like trying it elsewhere, but I still like Kansas City's best. And my favorite by far right now is Joe's KC. I'm not the only one. Anthony Bourdain put it on the list of places you have to eat before you die. And I've been to that one. That's the only one I've been to so far. I highly recommend it.
Excellent. Well, I really appreciate you taking the time out of your day to tell us all about Mycroft. It's definitely a very interesting project and one that I'll be keeping a close eye on as it continues to develop new capabilities. So thank you for that.
Been my pleasure, and we definitely, the more the merrier, joining into our project.